Good afternoon. Last week we talked about the enantiomers, and we mentioned that most of the properties of two enantiomers are identical, except the direction in which they rotate the plane of polarized light. And today we'll see what happens when we start having mixtures of enantiomers, and how do those mixtures interact with polarized light. And so if we said that certain enantiomer, let's say S, R enantiomer, turns light clockwise, and this is completely arbitrary again, while the S enantiomer turns light counterclockwise. The question is, what would happen if we had the one-to-one mixture of R and S of the same compound? Well, basically the two rotations would cancel each other out, and the resulting alpha would be zero. And such a mixture is called a racemic mixture, or a racemate, and it's sometimes also known as the plus-minus pair. For example, if we had a one-to-one mixture of two enantiomers of 2-butanol, so this would be S2-butanol, which turns the light by plus 13.5 degrees, and its enantiomer would be the R2-butanol, which turns the light by minus 13.5 degrees. One-to-one mixture of these two would turn the light in would not turn light at all. So the overall alpha would be zero. Now the question is, well, this is interesting, but why on earth would we prepare two enantiomers pure and then mix them so that we lose all the enantiomeric purity? Even though it seems a little bit of a special case, it's actually, racemic mixtures are actually very common. And the reason for this is deeply fundamental. It comes from the fact that you cannot create chirality out of nothing. I'll actually write it down. And what that means is that we have reactions which proceed on achiral starting materials with achiral catalysts. We cannot get a chiral compound. We will still get something that is achiral. Okay? But now, what if this achiral compound still has chiral centers? What happens to those chiral centers? Well, those chiral centers tend to form in one-to-one ratio. And so if we have simple bromination of butane, we start with butane, which is achiral, and bromine, which is achiral as well. And while we do introduce a chiral center, and if you remember the bromination of butane, we get exclusively the secondary product. This now is a chiral center, and we'll get both enantiomers on that chiral center in exactly one-to-one ratio. And that is where most of racemic mixtures are formed. Okay, so overall this mixture, even though individual compounds have chiral centers, the overall mixture is still achiral, and the overall rotation is accordingly zero. In more general terms, this is simply an expression of symmetry conservation rules, that symmetry remains maintained during the course of the reaction and cannot be randomly broken. This is, by the way, a very sort of fundamental question of organic chemistry, which is still not fully answered, and that is where did the chirality on Earth come from? Because even though we know that achiral plus achiral must give us achiral, Earth is full of chiral compounds, and in large excess. All amino acids, all sugars have certain chirality, and virtually none of the other enantiomers. And the question is, well, if we started with achiral compounds, and compounds react to give achiral mixtures, at which point was the first chirality introduced into living creatures on Earth? And that, again, is a question that's still not resolved. In the next topic, we'll see a little bit about how we quantify the compositions of mixtures of two enantiomers.